Hello friends, today OPSC lecture paper conducted by Odisha Public Service Commission part 2 from question number 20 to 40 I think, I don't know. Okay, so from today I'm going to discuss one question. Okay, question number 12 from previous part. Okay, part 1, the central deflection of a fixed beam carrying a central point load is x times the central deflection of a simply supported beam carrying same point load, the value of x. Okay, the value of x here asking. The central deflection of a fixed beam carrying a central point load is x times the simply supported beam. Okay, so we know fixed beam equal to 1 by 4 simply supported beam. Okay, equal to 1 by 4 times the central deflection of a simply supported beam carrying same point load. So 1 by 4, what is the value of 1 by 4? That is 0.25. okay, this is the answer. Okay, that is option A will be the correct answer. Okay, so I am going to question number 21. For the validity of a principle of a superposition, materials should behave in which manner? Linear elastic, non-linear elastic, non-linear inelastic, linear inelastic. So for the validity of a principle of a superposition, materials should behave in which manner? That is linear elastic manner. That is option A will be the correct answer. How many equilibrium equations do we need to solve generally on each joint of a truss? That is 1, 2, 3 and 4. So how many equilibrium equations do we need to solve generally on each joint of a truss? That is 2 is the correct answer. Question number 23. What is the degree of indeterminacy of a fixed support portal frame? What is the degree of indeterminacy of a fixed supported portal frame? Is 1, 2, 3 and 4. Fixed beam, this is fixed beam, okay. 6 minus 3 equal to 3. So option C will be the correct answer. How many degree of indeterminacy of a fixed supported portal frame? That is 3. Okay, in a deflection diagram, which is the following can have a zero angular deflection: pin supported, roller support, fixed support, hinge. So in deflection diagram, which of the following can have a zero angular deflection? Correct answer, fixed support. If it is asking about can't have a zero deflection in vertical direction, then hinge have not angular deflection. But here fixed support can have a zero angular deflection. The maximum deflection of a beam occurs at a zero slope location, zero shear force location, zero bending moment location, none of the above. So the maximum deflection of a beam occurs at zero slope location. That is option A will be the correct answer. A beam carries a uniformly distributed load throughout its length. In which of the following configuration will have maximum strain energy? Cantilever beam, simply supported beam, propped cantilever beam, fixed beam. So correct option will be the cantilever. Question number 27. A fixed beam of span 4 meter has a hinge at C At a mid-span, a concentrated load of 100 kilonewton is applied at a C. What is the fixed end moment at end A? It is given that a fixed beam okay, of span 4 meter, this is A, this is B, span meter has a hinge at a C midpoint, that this is, suppose this is midpoint, hinge at a C. A concentrated load 100 kilonewton is applied at a C. What is the fixed end moment? Fixed end moment at A means WL by 4, that is 100 into 4 by 4 equal to 100. Double L by 4, that is 100 into 4 by 4. So answer will be the 100. Sorry, 100. Okay. 27 option B will be the correct answer. 28 a fixed beam of a uniform cross section is loaded with uniformly distributed load throughout the span. The proportion of a bending moment at the center to the end moment. Okay, it is given that a fixed beam of a uniform cross section is loaded with uniform distributed load throughout the span. The proportion of a bending moment at the center would be okay, this is fixed beam, the UDL, okay, UDL, uniform distributed. So the proportion of bending moment at the center is at W square by 24, and center to the end moment, bending moment at the end moment, W square by 12. So when we divide WL square by 24 with WL square by 12, it will come as 1 by 2. So answer will be the 1:2. That is option B will be the correct answer. The slope and the deflection of a beams of a varying flexural rigidity may be easily computed by McCloy method, Mohr method, conjugate beam method, moment distribution method. So here conjugate beam method will be the correct answer. Option C will be the correct answer. So a analysis of a portal frame becomes essential when a loading is unsymmetric. Frame is unsymmetric, both frame and loading are unsymmetric, all the above. Here so a analysis of a portal frame becomes essential when loading is unsymmetric, correct, frame is unsymmetric, correct, both frame and loading are unsymmetric, correct. Option D correct. So option D will be the correct answer, that is option D. 30 question number, option D will be the correct answer. Limit state method is based on calculations on service load conditions alone, calculation on ultimate load conditions alone, calculations on working load and ultimate loads, calculation on earthquake loads. So here option C will be the correct answer, that is calculations on working load and ultimate loads. Calculation on working load and ultimate loads is the correct answer. The minimum clear cover to the main reinforcement bars in column, beam and slab is respectively given as we know for a slab. We know for slab it's a 15 mm, for beam 25, for column 40. So here column this is 40, beam this is 25, for slab this is 15. So option B will be the correct answer. Question number 33. The maximum longitudinal reinforcement in an axially loaded short column is a dash percent of a gross sectional area, that is 4%, 5%, 6%, 8%, Here the maximum longitudinal reinforcement in an axially loaded short column is 6% of cross section area. That is option C will be the correct answer. Question number 34. The maximum compressive strain permitted in a RCC column subjected to axial load and bending is 0.0020, 0.0030, 0.0035, 0.0040. So here correct option is 0.0035. So the maximum compressive strain permitted in RCC column subjected to axial load and bending is 0.0035. Option 3 will be the correct answer. Next question. The ratio of the strength of a helically reinforced short column to that of a tight column is the ratio of the strength of a helically reinforced concrete short column to that of a tight column is 5% more, is 5% more, that is 1.05. Option C will be the correct answer. 36. The primary compression failure in RCC beam is caused in under reinforced beams, over reinforced beams, balanced beams, all the above. So here it is asking about the primary compression failure. So primary compression failure in RCC beam is caused in over reinforced section beams. That is option B will be the correct answer. If here it is asking about to primary ductile failure, it's the option A under reinforced sections. If also it is the secondary compression failure, then under reinforced beams. Okay, but here it is asking about primary compression failure, so we have to choose over reinforced beams. So option B will be the correct answer. If it is asking about secondary compression failure, then it will be the under reinforced sections. Next question. Steel beam theory is used for a design of a simply steel beams encased in concrete, doubly reinforced beams ignoring compressive stress in concrete beam if shear stress exceeds 2 times allowable shear stress. So steel beam theory is used for doubly reinforced beams ignoring compressive stress in concrete. That is option C will be the correct answer. Option C will be the correct answer. 37, 38. The shear reinforcement in RCC beam is provided to resist flexural tension, flexural compression, diagonal tension. So here correct answer will be the diagonal tension. So the shear reinforcement in RCC beam is provided to resist diagonal tension. Next question. The unsupported length between end restraints shall not exceed dash times the least lateral dimension of a column. The unsupported length between end restraints shall not exceed dash times the least lateral dimension of a column. That is option A 50, 60, 70, 80. So here correct answer will be 60. Option B will be the correct answer. Limits the design permissible bond stress in case of a deformed bar. In case of a deformed bars is more than that plain bars by 60%, 50%, 40%, 25%. In limit statement, the permissible bond stress in case of a deformed bars is more than that in plain bars is 60%. That is option A will be the correct answer. But here if it is asking about to in compression case, in case of a compression, so it is increased by 25%. Okay, limit state of a serviceability for a deflection including the effects due to creep, shrinkage, temperature occurring after erection of partitions and applications of finishes as applicable to floors and roofs is restricted to span by 150, span by 250, span by 300, span by 350. So it is asking limit state of serviceability for deflection including effect due to creep, shrinkage and temperature. Creep, shrinkage and temperature. Creep, shrinkage and temperature. So it will goes to span by 350. When it is asking about to final deflection, deflection final deflection, then it will be span by 250, but here option D will be the correct answer, that is span by 350. When it is asking about to final deflection, then it is span by 250. Question number 42. In case of a two-way, the limiting deflection of the slab is primarily a function of the long span, primarily a function of the short span, independent of a long or short span, dependent on both long and short span. So here correct answer will be the primarily a function of the short span, that is option B will be the correct answer. Side face reinforcement shall be provided in the beam subjected to bending moment, shear force and a torsion when the depth of a beam exceeds option A for 50 mm, 500 mm, 600 mm, 750 mm. So it is given that when side face reinforcement shall be provided in the beam subjected to bending moment, shear force and a torsion, but here it is one more, that is torsion. When you have to remember, when torsion exists, then 450, when there is no torsion then it is 750, but here it's a bending moment, shear force and torsion given. When torsion exists it's a 450, so here correct option A. The deflection can be controlled by using the appropriate, this is a span by depth ratio, option D will be the correct answer. In limit state approach, spacing of main reinforcement controls primarily collapse, cracking, deflection and durability. So it's a option B, that is cracking will be the correct answer. I'll discuss from 46 to next 70, 65, 70 question in the part 3. This is part 2. Thank you so much. If you want question paper, then I will give you, then you have to comment your mail ID in the comment box. Thank you. So it may give you some importance because OPSC AAA आ रहा है next month में, so it may help you. So thank you guys.